Good morning, this is P. Venkata Mahesh, Assistant Professor in Mechanical Engineering Department, Institute of Aeronautical Engineering. We were discussing one subject called Applied Thermodynamics, which is meant for 6th semester Mechanical Engineering students, and in that we were discussing one topic of IC engines. And in this class we will discuss what is the working of 4-stroke IC engines. So as we have already seen, we have in IC engines we have two types. One is a 2-stroke engine and 4-stroke engine, and in this class we will see how this 4-stroke engine works. Now here if you see what is the basic difference, if you remember, in the last class we have seen that this is the piston that is moving up and down, and during this up and down motion there is a power stroke. And here also the piston is moving up and down and there is a power stroke. And now this is intake, and now here combustion happens and again exhaust happens. So in one cycle of this crankshaft there are 2 strokes, and in this upward stroke and backward stroke we have a power stroke. And now here if you come to the 4-stroke engines, now if you see, this is intake stroke, compression stroke, combustion stroke, and the exhaust stroke. So we have 4 strokes for one power stroke. So for one power stroke to complete, we have 4 strokes in this engine. One is a suction stroke, compression stroke, expansion stroke, exhaust stroke. So that is the reason it is called as a 4-stroke engine. And in this we have 2 revolutions or the 2 rotations of this crankshaft for one power stroke. And coming to the 2-stroke engines, all these 4 strokes are combined in 2 strokes itself, so that for 2 movements or the backward stroke and forward stroke we have a power stroke. And this is the 2-stroke engine. Now we will see how the 4-stroke IC engine works. So we have 2 types of IC engines. One is auto engine, the other one is a diesel engine. So the auto engine or the petrol engines or the gas engines. So the auto 4-stroke cycle engines are the engines in which we use the petrol or gas or other light oil engines. Now in this kind of engines, what we'll do is we'll take mixture of air and fuel. Okay, so the mixture of air and fuel is drawn into the cylinder and it is compressed, and at the end of the compression stroke will ignite a spark with this ignition system, and with that spark there is a combustion that takes place, and then there is a expansion and exhaust stroke. So this is the brief introduction. And if we see, we have inlet valve. So this is the inlet valve, this is the exhaust valve, and this is the cylinder of the engine, and this is the crankshaft, and this one is the crank which is rotating like this, and this is the connecting rod which is connecting the crank and the piston, and there is a spark plug. This is the spark plug which gives us the spark at the end of the compression stroke. Now what is this suction stroke? The suction stroke is also called as the induction stroke. Why? We are inducing we are allowing the air fuel mixture into the cylinder. Now here, before this suction stroke starts, the piston will be at the TDC, the top dead center, and this is the BDC or the bottom dead center. So in this, during the suction stroke, what happens is the cylinder moves from the TDC to BDC. So the during the stroke, what happens when it starts from the TDC? When the piston starts from the TDC, theoretically the inlet valve is supposed to open, and as this piston goes down, the appropriate amount of air fuel mixture is sucked into this cylinder, in which the vacuum is created by the movement of the piston from TDC to BDC, and this operation is represented by the line 5-1. Okay, the 5-1 line is the suction stroke. The 5-1 line is suction stroke. Now here, this is the atmospheric pressure line. Now during the suction stroke, what is happening is we are sucking the fuel, air fuel mixture inside this. So how it happens? Because of the lower pressures that is caused inside the cylinder. So that's why the suction line is below the atmospheric line. Now during this stroke, during the stroke, that is the movement of the piston from TDC to BDC, so from the TDC to BDC, the inlet valve will be open and the exhaust valve will be closed. Okay, so this is the suction stroke. So the next one is compression stroke. So the compression stroke means the piston from BDC, it will move towards the TDC. So if piston moves from the BDC, bottom dead center, to the top dead center, and in this stroke, during this stroke, both the inlet valve and the exhaust valve are remain closed. Okay, they both will remain closed. So because of that, what happens is, whatever the air fuel mixture trapped inside the cylinder, it will get compressed to about 8 bar. So at the end of the compression stroke, the pressure of the air fuel mixture will be around 8 bar. Now just before the compression stroke ends, what happens is the spark plug will give some spark and the combustion starts. So the line 1 to 2 represents the compression stroke, where the pressure increases, and 2 to 3, what happens is, because of the combustion, the pressure further increases. Now during the combustion, what happens is, the air fuel mixture that is there, it will get ignited by the spark, and high temperature gases will form because of the combustion of the air fuel mixture. And this the hot gases, what they will do, they will push the cylinder push the piston downwards. So after the combustion gases, they will exert a lot of pressure on the cylinder, and the piston starts moving from the TDC to BDC. Okay, the TDC, from the top dead center to the bottom dead center, the piston will be pushed, and this stroke is called the expansion stroke or working stroke, and this is the only stroke during which the power is developed by the engine. So during this this cycle, when this stroke is represented by 3 to 4 line in this PV diagram, and during this stroke also, the inlet valve and the exhaust valve, they remain closed. So okay, they remain closed, and what happens is, at the end of the this stroke, at the end of the stroke, as the piston moves towards the TDC, okay, I mean towards the BDC, from TDC to BDC, the power stroke happens, and when the piston reaches the BDC, the exhaust valve opens, and the exhaust stroke starts. Now, what is this exhaust stroke is all about? The exhaust stroke is because of the movement of the piston, all the exhaust gases, that are the waste gases from which we have already extracted the power, they will be pushed out of this exhaust valve. So that is why it is also called the scavenging stroke. Okay, and this line is represented by the line 1 to 5 in this PV diagram. So the 1 to 5 is exhaust line, and the 5 to 1 is the suction stroke. So, and the remaining 1, 2, 3, 4 is our the air standard cycle is 1, 2, 3, 4, but the actual cycle is 5, 1, 2, 3, 4, 5. Okay, so this is the indicated diagram of the 4-stroke IC engine or ignition SI engine or spark ignition engine. The spark ignition engine or the Otto cycle engine, for this this is the indicated diagram. Now, what is the difference between the ideal indicated diagram and the actual indicated diagram? So the actual indicated diagram, if you see, from 5 to 1, it should be a constant pressure. Okay, the pressure should remain constant. But in actual practice, because of the wire drawing effect of these valves, so what happens is there is the pressure inside the cylinder will be lower than the atmospheric pressure. Okay, so the restricted area of the inlet valve, okay, here the valve, the area is restricted, and there is something called the wire drawing effect that we have already discussed. Because of this wire drawing effect, what happens is the pressure will be below the atmospheric pressure. And now, what is the other deviation? The other deviation is the exhaust stroke. So again, while the gases are leaving the exhaust valve, again we have the restriction of the passage because of this valve, and because of that, what happens is the pressure is slightly more than the atmospheric pressures. So this is the major deviation from the ideal indicator diagram and the actual indicated diagram. Now this actual indicated diagram, the area between 4, 5 and 1, this 4, 5 and 1, this is a negative loop. Okay, this is a negative loop, and it gives the pumping losses due to the admission of the air fuel mixture and removal of the exhaust gases. So in drawing the air fuel mixture inside and pushing the exhaust gases outside, some loss, the power will be lost, and that power loss is given by the 1, 5, 4. Okay, the 4, 5, 1, this loop is giving that this area is giving the power that is lost in the suction and exhaust cycles. And the area under 1, 2, 3, 4, the area under 1, 2, 3, 4 gives the net work, the gross work obtained by the piston. Okay, the gross work obtained by the IC engine is given by 1, 2, 3, 4. If I subtract the 451 from this, what I will get is the net work obtained by the IC engine. So the net work is given by 1, 2, 3, 4 and the losses are given by 451. If I subtract the area under 1, 2, 3, 4 by the area under 451, I will get the net work obtained or developed by the SI engine during the 4 strokes that are discussed. So the next one is diesel engine. So the diesel engine, what happens is will suck or will take only air. Okay, will take only air and will compress it, and because of this compression, and at the end of the compression will release the fuel, okay, inside this highly compressed air. So when this fuel comes in contact with the highly compressed air, the compression starts automatically without any requirement of the spark plug. Now that is the reason they are called as compression ignition engines. So the diesel engines are called compression ignition engines and the Otto cycle engines are called the spark ignition engines. That is the only difference between the spark ignition engine and the diesel this compression ignition. That is the major difference. Okay, the other difference is will take only air in diesel engine, will take air fuel mixture in the petrol engine or SI engine. Now what are the strokes in the diesel cycle? Now in the diesel cycle engine, again the suction stroke is there. So this suction stroke, during the suction stroke, the inlet valve opens and the piston moves from the top dead center to bottom dead center. So this is the top dead center and this is the bottom dead center. The piston moves from the top dead center to bottom dead center, and because of that, what happens is the air is allowed to pass through the valve into the cylinder, and during this stroke the exhaust valve will remain closed and the operation is represented by the line 5 to 1. So the 5 to 1 is representing the suction of pure air inside the cylinder. That is the suction stroke. So what is the next stroke? The air that is taken inside the cylinder, it will get compressed when the piston moves from the bottom dead center to top dead center. So the piston moves from the bottom dead center to top dead center, and the pressures and the temperatures are very high because of the compression ratio, and the pressures that the air reaches are up almost 35 bar and 600 degrees respectively. So the previously it was only 8 bar in case of the S engines or the spark ignition engine, but here the compression ignition engine, the pressures are as high as 35 bar and the temperatures are also as high as 600 degrees centigrade. Now during this compression stroke, the valve, the inlet valve and the exhaust valve also they remain closed. The inlet valve and exhaust valve, they remain closed during the compression stroke, and almost at the end of the stroke, as the piston reaches the TDC, will spray the fuel. Okay, we will spray the fuel inside the IC engine through this fuel injector. There we have spark injector or spark injector, and here we have the fuel injector. So this there will induce the spark using some electric energy, and here just will spray the fuel on the highly compressed air, and automatically the fuel starts burning at constant pressure, and that is indicated by the line 2-3. The combustion process is indicated by the process 2-3. It is supposed to be, ideally it is supposed to be like this, but actually there is some increase in the pressure. Now the expansion stroke or the working stroke, which is the only one stroke during which we will get our pressure, our work done in this CI engine or a diesel engine. Now in this stroke, what happens is both the valves remain closed, and the piston, because of the high pressures of the combustion that is happening here, it will be pushed from the top to the TDC to the BDC, and this is called the expansion stroke or the working stroke, during which the power is given to the IC engine by the working fluids. And as the piston reaches the BDC and it starts moving to the TDC, what happens is the exhaust valve will open, then the waste gases from which we have already extracted the power will be pushed out of this exhaust valve, pushed out of the engine through the exhaust valve, and this operation, which is called the exhaust stroke, is represented by 1 to 5. So the 1 to 5 is representing the exhaust stroke, and 5 to 1 is representing the suction stroke. So this is the exhaust stroke. Now how the actual and ideal indicator diagram are look like. So this is the ideal indicator diagram and this is the actual indicator diagram. Now if you see, the wire drawing effects of the inlet valve and the exhaust valve are causing some deviation from the ideal indicator diagram and the actual indicator diagram. So because of that, what is happening is the suction pressure, the pressure during the suction stroke is slightly below the atmospheric pressure, and the pressure during the exhaust stroke is slightly above the atmospheric pressure, and this is happening because of the restricted area between the valve and the port, this valve seat and this valve. So this is the inlet valve and this is the exhaust valve. During the suction and the exhaust, the area is restricted by the valve, and because of this restriction in the area, the pressures are not atmospheric pressures. Rather, during the suction stroke, the pressure is below the atmospheric pressure, and during the exhaust stroke, the pressure is above the atmospheric pressure. Now the loop, again the same thing, the loop 451 is indicating the pumping losses because of the admission of the air, fresh air, and removal of the exhaust gases. Some work will be consumed by the IC engine, and that work is the negative work, and the cycle 1, 2, 3, 4, which is the main cycle, which is producing the work. This area under 1, 2, 3, 4 gives us the gross work that is produced by the CI engine, and the area between 1, 5, 4 or 4, 5, 1 will give the negative work that is taken by the suction stroke and exhaust stroke. So the net work that is produced by the CI engine is given by the area under 1, 2, 3, 4 minus area under 1, 5, 4. So this is about the diesel engine. So the diesel engine working, we have seen 4-stroke diesel engine, and we have also seen the 4-stroke IC engine. Now we will see the working of two-stroke engines. How so far we have seen the working of four-stroke engines, and now we will see the working of two-stroke engines. How they work like this. Now in 1879, there is a scientist called Douglas Clerk in in Britain. There is an engineer called Douglas Clerk. He introduced a cycle which completes this the four strokes of the IC engine in just two strokes, and that is called the two-stroke cycle engine. Here what he did is he removed the valves, the inlet valve and exhaust valve. In place of that, what he has done is there is a port, inlet port, transfer port and exhaust port, and using these three ports, what he did, he completed the four strokes of the IC engine into two strokes, and we'll see how that two-stroke engine works. So this is the two-stroke engine working. Now it is two-stroke engine also. We have two types. One is auto engine, the other one is diesel engine. So the two-stroke auto engine or petrol engine, they were used in the two-wheelers, but the two-stroke diesel engines are rarely used. Now here, what is happening here, we have to see. Now, if you see the parts, the inlet port or induction port is there. So this is the inlet port or induction port through which the fresh charge is taken inside this crankcase. Okay, inside this crankcase, the fresh charge is taken, and there is an exhaust port. The exhaust port, through this exhaust port, all the exhaust gases are thrown away. Now, what is this transfer port? So, the transfer port is the one through which the slightly compressed the air fuel mixture is allowed inside the cylinder. So, this air fuel mixture from the crankcase is passed through the cylinder through this transfer port. Now, in auto cyclic engines, again the combustion happens because of the spark, and in the diesel engines the combustion happens because of this fuel that is sprinkled on the highly compressed gases. Now we'll see what are these strokes in the two-stroke engine. So in two-stroke engines we have only two stroke. One is upward stroke and other one is the downward stroke. So what is the upward stroke? So the piston moves from the BDC to TDC. So the piston moves from the BDC to TDC. So what happens during this? The piston valve closes the transfer port and exhaust port. As the piston moves from BDC to TDC, the piston closes the transfer port and the exhaust port, and the whatever air fuel mixture that is taken in the downward stroke inside the cylinder, it will get compressed, and at the end of the compression, what happens is the spark is produced by this spark plug and the combustion happens. Okay, here this is one side of the piston, this is happening. So on the other side of the piston, what is happening is the air fuel mixture is drawn into the crankcase through this inlet port. So the air fuel mixture is drawn into the crankcase during the motion of the piston from BDC to TDC. So as the piston moves from BDC to TDC, the fresh air is taken inside the crankcase, and whatever is there inside the cylinder, that will get compressed. Now, at the end of this upward stroke, what happens is there is a spark that is ignited, and the combustion starts, and uh, the piston is pushed down by the high pressure gases because of the combustion. So that is the combustion stroke. That is the combustion process. And what happens to the piston is it will start moving from the TDC to the BDC. Now this is the downward stroke. The piston is moving from the TDC to BDC, and this is called the downward stroke. And this, during this downward stroke, what happens is the pressure, the pressure that is built by the combustion process, it will exert a lot of work, a lot of pressure on the piston, and this is the power stroke. And what happens as it moves down, what happens is the transfer port and the exhaust port, they will get uncovered. Okay, so initially the transfer port and the at the TDC, both the transfer port and exhaust port will be closed, and as it moves down during some point, the transfer port and exhaust port will be open, and the inlet port will be closed. So that time what happens is the air fuel mixture that is coming from the crankcase will remove the exhaust gases, and they will be thrown out of the cylinder. Okay, both the suction and the exhaust are happening during one process, and this process is called scavenging process. So the fresh air is removing the old residual gases, and that process is called the scavenging process. And coming to the diesel engine, so the same thing you can see here in case of two-stroke diesel engine also. So what is happening in the two-stroke diesel engine? The combustion process is happening without any spark, but with the fuel injected inside the high pressure gases. So how it happens here, we have to see. Now again, the upward stroke, here we have only two strokes. The one is upward stroke and the downward stroke. All the compression, suction, power and exhaust, all these four strokes are inbuilt in these two strokes, the upward stroke and downward stroke. So what is this downward stroke doing? Now the upward stroke, the piston moves from the BDC to the TDC. So during this stroke, what is happening is the piston valve will close the exhaust port and the transfer port. So there is the exhaust port and the transfer port are closed. At the same time, the inlet port is open. So the one side, the air that is trapped inside the cylinder will get compressed. The other side, the fresh air is induced into the crankcase. So during the upward stroke, the compression is also happening, and as well as the fresh air is also taken inside the crankcase. And what is happening is, at the end of the stroke, when the piston reaches the TDC, the fuel injector will spray the fuel inside the combustion chamber. So what happens is, inside the cylinder, the combustion happens, and because of that high pressure, the piston will start moving from the TDC to BDC, that is the downward stroke. So the downward stroke, what happens during the downward stroke is the inlet port will be closed and the transfer port and exhaust port will be open, and what happens is the whatever the gases, fresh gases that are taken in the previous cycle, that will be transferred to the transfer port to the engine, and it will scavenge whatever the exhaust gases into the atmosphere. So the compression, this is the exhaust stroke that is happening, and the power stroke is happening during the downward stroke, and during the upward stroke the suction as well as the the compression is happening. So during the upward stroke the compression is happening, and during the downward stroke what is happening is the combustion, the power is developed, as well as the air is pushing the gases, the air is pushing the gases through the all the exhaust gases through the exhaust port. So this is about the two stroke diesel engine. Now what is the difference between the two stroke engine and four stroke engine? So this four stroke engine, the cycle is completed in 4 strokes of the piston or the 2 revolutions of the crankshaft, and in two stroke engine the cycle is completed in 2 strokes of the piston or 1 revolution of the crankshaft. So thus 1 power stroke is contained in every 2 revolutions of this crankshaft in case of 4 stroke engine, and 1 power stroke is obtained in each revolution of the crankshaft in the 2 stroke engine. Now with this we'll conclude for today, and in next class we will see what is the wall timing diagram and port timing diagram, how to draw that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.